Hey everyone, welcome back to the lab. In this video, we're going to be talking about what it's like to run HTMX in production. Stories from experienced software engineers. So HTMX is changing how modern web apps get built. It provides most of the capabilities of a single page application with the simplicity of a multi-page application. This basically means that you don't really need to reach for React or Vue or Angular or Svelte or any of those other front-end web frameworks just to build a modern app. And in most cases, it's actually simpler not to. But all technologies make really big promises and really big splashes early in their hype cycle, while few survive the test of running in production for a few years. So in this post, we're going to survey the experiences of real developers who have tried running HTMX in production to see if it works well or if it's all just hype. All right, so here's a general overview of kind of what we're doing in this post. So all the developer responses that I gathered here are from our experienced devs on Reddit for this post. And basically I got themes in terms of like problems and benefits and experience and stuff like that. By kind of sifting through all the responses that we got there, organizing them by theme and idea, and then kind of condensing them down into learnings and takeaways that are more generalizable to those building web apps. And so in the rest of this post, we're going to be exploring those themes, the good and the bad, what we can kind of learn for them, and how this might affect your HTMX tech stack decisions in the future or your implementation decisions. So the first theme here that HTMX is good for is that it simplifies front-end code. And this should be no surprise. Here's kind of like my understanding of, the complexities and benefits of HTMX versus a multi-page application and a single page application here. This comes from my HTMX for Side Projects post, which is linked here as well. And the general idea is that, multi-page applications, they're hard to make super high user experiences with because they really kind of rely on the browser, and the browser in core HTML has a lot of constraints. And so this makes it very hard to get high user experiences. The main issue is that you have to do a full page reload instead of a partial reload, which is obviously very slow. But it's actually very simple to make multi-page applications. You only need one thing. You can just server-side render it, you send it, browser does it, and you're done. On the other hand, we've got single-page applications, which basically allow you to get the best user experiences, the most dynamic things you could ever imagine on the web. But to do that, they required a lot of bending the rules, extra infrastructure on top of what the browser is capable of to get you that thing. And so the complexity also is basically the highest we've ever seen for any kind of web app. And this is where HTMX comes in, where it's well, I can give you the user experience, most of the user experience you get from SPAs, for just a little bit of extra complexity. And this is really kind of where it shines. And so it's no surprise that people's actual experience kind of aligns with this. So you can go in here for more information about this graph, but let's get started with, developers' kinds of feedback on this. And so the majority of responses that praise HTMX are praising it for vastly simplifying front-end code. And what this simplification allows is two major benefits. One is the ability to do faster changes, so faster change velocity in your app, new features, bug fixes, etc. And the second one is actually it's easier to onboard new developers to this, largely because the code is simpler, so you don't have to learn all of these kind of domain-specific languages, which each of these web frameworks is, and kind of all of their stack choices in terms of state and stuff like that. So that's the general gist, but let's dive into specific responses. So here's one response on front-end simplification, and really focused on reducing the layers of abstraction. And so this user says, from what I can see, HTMX strips back a lot of the layers of nonsense that was going on before. We do have some JavaScript, but we use it mostly for the original intent of little bits of interactivity. That doesn't need to touch the server. Things like flipping on dark mode. Now, I feel this very strongly. A lot of the work in full stack CRUD apps is simply piping data from the database to the backend to the front end. And I consider myself basically a backend web developer. I do backend, but it's basically only for web-based services. And in all my experience working at, Instagram, Fang, small company, medium-sized scale up, basically everything we build is a full stack CRUD app. That's all it is. And so if you can simplify the building of that, you actually vastly simplify the work across an entire tech stack. And my general gist of this is when you have a single page application, basically the flow of data needs to go from the database to the backend logic, and then it needs to create JSON or whatever your intermediate representation is. Maybe you're using gRPC or something like that. And then it needs to go into the front end logic to kind of deduce what that thing is. What does it mean? And then it comes out and produces HTML because the browser speaks HTML. or hypermedia, and so that is what it's going to understand, and that's what it needs to eventually come out the other side of. Now, if we look at what multi-page applications do, and basically HTMX is the same, it's just a little bit of sprinkled stuff on top of multi-page application. All it does is it gets the database, or the data from the database, and then of course it still needs to do some translation to be like, what do I need to show the front end? But what it does is it just produces HTML and then just sends it to the browser, and that's done. And so it's pretty clear here just looking at the steps that, this MPA route is just much simpler. It only has 3 steps instead of 5. And so, we're able to get that spa-like experience, but for the simplicity of a multi-page application. And so that's kind of how we're able to, reduce these layers of nonsense. There's just this useless, mindless plumbing that we have to do, but is actually a source of a lot of complexity and a source of a lot of breakages, even though it's not doing anything useful. The next kind of theme for front-end simplification is that we can actually take this even further and not need JS at all. And so this user says, most of our apps have 0 JavaScript outside of the HTMX page now. And all of our apps that I've done so far, there's no need to have any JavaScript or even jQuery on our pages if we can just post back and get the out-of-band updates that we need. And this is basically how HTMX works. If you have some data that you want to do, you just send it to the server responds with the HTML, and that's what you use for the HTML. And the previous user was saying like, they still have JS for a little bit of interactivity, but truly a lot of apps are mostly static. And for those kinds of things where the interactivity is like minor, you can actually get away with very minimal, even to no JS, which I think is interesting. And so when you really think about what makes spas feel modern, it's mostly that they feel fast, and that's largely due to targeted partial page re-renders. I have a whole essay on how this is true. So if you don't like it, just read my argument here. The way that spas do this is in all sorts of ways. They've had to kind of add extra layers of infra and stuff on top of what a browser does, because a browser, HTML, etc., that doesn't do that out of the box. And so they do this in a generally pretty heavyweight state to DOM mapping. And so this allows them, when the state changes, kind of in the app, they figure out what parts of the DOM are affected and just re-render those. What HTMX does is it basically allows you to do the same thing, but without this state portion. Instead, it's basically just DOM. And so you get the same functionality, but in a much lighter weight form, because we don't have this intermediate state that we need to handle or keep track of, or that our infra needs to do. We literally just send DOM based on state, and that's it, based on server state, I should say, no client state, and that's all there is. And what this allows, of course, is this idea of like, you get everything you would usually need JS for, that you might enlist these frameworks for, but without it, you just build it once on the server and you're done. More on this here. All right, so what does this allow? So one of the big benefits of this kind of simple paradigm is that we get faster changes. And so here's what this user says about this. I've been using it recently for some internal facing apps, and I'm really happy with it. No concern for scaling due to the nature of the apps, but it's super simple to get up and running quickly. So because the front end is simplified, making changes is quite fast. You can essentially just build an MPA, which basically anything can do. It's literally just build the raw HTML string, or if you have a template library, build, with their tools, your HTML on the server, and you just send it. And then all you do is you sprinkle in the HTMX where you need it, which is usually only in a few places for things that need to re-render. And that's it. You're done. You don't have to fiddle around with React. You don't have to fiddle around with Redux state or whatever, hooks you're using. You don't have to figure out like all these layers of abstraction for how to get from this thing to send an event, to tell the handler to go kick off a request, to go, send it to the front end so that you can then re-render whatever widget you have. You literally just say, hey, go ask that thing for the new HTML. And that's it. So you get much, much, much faster changes. And honestly, these internal facing apps, I think, are an excellent use case for this because it's so low risk that I think this is a great entry point for people to try this stuff. And what you're going to realize is that the reason people are paying Retool the big bucks for like building internal dashboards and stuff is because front-end development is so convoluted and hard to do the simplest things that it's actually better to pay these, companies hundreds of thousands of dollars, millions of dollars a year to use their WYSIWYGs only because we made front-end hard. But if you just use HTMX for these internal dashboards, you can build it so fast. And you're like, oh my God, is this how web dev could be? And so I think this is a great use case for this, and it really kind of shows the power of HTMX. Okay, the next benefit is kind of like a sub-benefit that just happens because it's easier to make changes, faster to make changes, simpler code, and that's it's easier to onboard new developers. And so this user is saying, I'll answer how it scales for a small team in my opinion where I work. I use it in my production apps at work. I will say that one of the best parts of it is that when a feature request, bug fix, or enhancement comes in, pretty much anyone can pick it up. I built Angular apps and React apps, and unfortunately, even making text changes in those systems can be too difficult for a junior developer to make the change if they've never worked in that environment before, and forget about complicated logic changes. And so in my view, front-end code has gotten so complex that many orgs now have specialized positions for front-end and back-end. In practice, this means that it's very hard for any one developer to get a full stack changeout, because most changes, let's be real, especially any change with real substance, needs to kind of handle both. And so what this means short term is that all changes incur extra costs due to context switching and collaboration overhead between front end and back end. So let's say I need to change, like this text thing. Where does that live? Is it on the back end? Is it on the front end? Well, I gotta probably start at the front end and kind of parse backwards to figure out where did that thing come from? But if the code is so complex that it needs a specialist, and I'm not a specialist in that realm, then now I got to learn this whole new stack to kind of figure this out. And so it incurs this extra cost where I have to context switch technologies, context switch repos, context switch paradigms. I have to probably, ask a specialist there to take time out of their thing to help me. And so just for simple changes, the kind of mental overhead gets so high that whole end-to-end process of development slows down. And so that's just short term. What happens when we do this long term, over time, across repos, across, developers and stuff? Long term, what this means is a general architectural bias against doing things full stack. And so what this means is that both sides will go to great lengths to not have to do things full stack, which often leads to suboptimal architectures throughout. So you can imagine, if we have a holistic architecture, but we have a very painful bottleneck, we'll say we're going to do everything we can to kind of not deal with the bottleneck. Okay, but the thing is, most apps need to work end to end, right? We got the data over here, we got the back-end logic over here, and then we got front-end logic over here. And so if this is the bottleneck, we are going to build things that optimize for one, but not the whole. And you can quickly see how making these kinds of local maxima does not lead to an actual global maxima of what the architecture should and could be. And in my opinion, this is how we got all these heavyweight client state management things like Redux, because we wanted to change things without ever having to talk to the server, because painful. Interesting RPC protocols like GraphQL. Why do we need this? Because we haven't separated two things that are actually necessary, the core calculation logic and the presentation logic. We've separated them, and so now we need ways to better talk to them, connect two things where they're separated but didn't need to be. And this push towards JS-only stacks, Next.js, Nuxt, SvelteKit, etc. These are all methods to try and lower the pain of that front-end, back-end communication, that bottleneck that exists. And so for most orgs, what they really want is to build useful software. And so choosing technologies that are so simple that anyone can make a change, whether they're a junior or senior, whether they're more back end or front end, this is going to lead to better velocity and thus business outcomes over time, because you're not bottlenecked. You're not having to build these crazy complex systems to solve for a problem that shouldn't even exist in the first place. And so I think the general theme of this is really that HTMX allows devs to be full stack. It doesn't make each area so complicated that you need to be a specialist in it just to make a simple change. So backend people can do front end, and front end people can do backend. Okay, so another theme around HTMX being good is that it often is more performant than respective spas. And so this user says, HTMX lets us ship 90% of our page from CDNs, and then the HTMX talks to servers, unlike how JS server-side works. And really, I think they're talking about JS web frameworks, where it's kind of server-side driven, but can't really be cached because it's behind all those bundles and stuff, although they have gotten pretty good at this. So he says, we have a custom CDN server that is designed on top of DPDK. I don't know what this is. So we like serving as many chunks of static content out of that as we can, since it's well over 10x higher throughput and 50x lower latency than their SPA alternative. And so one of the big complaints I see against HTMX is that it won't be performant. You're using a network call for every piece of page interactivity. And that is a fair point. Network calls are much more expensive than local calls, and this is honestly one of my big arguments against microservices, because they make all local calls into network calls, which is worse, obviously. But in practice for HTMX, this isn't really a problem. Now, I want to caveat this because I do think, network calls unbounded, very bad. But we have to think about how do we actually use this in the real world to understand what is the actual impact of that on our systems. And so if you naively use HTMX for everything, so you're naively putting network calls in place of local calls everywhere, then yes, it can be bad, as we're going to talk about later, a case where someone did this. But if you use it reasonably, then it's mostly the same and often better than SPAs at performance. And here's why. So for server interactivity, HTMX is great. This is anything that needs data from the server. And when you think about it, any substantial change requires an ask to the server, because the server is what owns the data. And so if you have any substantial data that cannot fit on one page or has logic that's too complex to only work client side, then you need this interactivity, okay? There's no solving that with HTMX. We need to make it. There's no solving that with client side. You're going to need to make that data change. And so for server interactivity, use HTMX. Examples of this is submitting data, because obviously you're submitting it somewhere. It needs to save, it needs to update or whatever. Another one is sorting a data table. If it's, more than, I don't know, let's say 50 items, right? Then that means you're going to have a lot of things in the DB, and the sorting needs to happen on the database so that you can actually get, deterministic sorting, deterministic pagination, stuff like that. And then for refreshing of data, because you're going to need to ask the source of truth what's there. All of these require server interactivity. You cannot get around that, no matter what client-side technology you're using. Now for client interactivity, then yes, use something else. Don't use HTMX. And this is anything that does not need data from the server. So this is things like choosing light versus dark mode or toggling a pop-up, stuff like that you can only do client, then sure, HTMX is probably bad. And yeah, you're going to get a bad experience if you're waiting on network calls for all these things. Now for more on when you should use each of these, HTMX and versus Alpine, you can check out this post here. Okay, now for server interactivity, HTMX does less work than client-side frameworks. This is because client-side frameworks need to do the same network requests plus their own internal processing to render, as we saw last time. And of course, these kind of requests for more data are often bad at overfetching, underfetching, or they are doing multi-fetching for something that, the backend could have just done a bunch of local calls for, no network at all. And so HTMX simply does the request and plops it on the page, which means it must be doing the same or less work than client-side frameworks, no matter what, okay? That's just how it is. Now, the only case where HTMX does more work is for client-only changes, in which case maybe, don't use HTMX for that. Just use JS or Load.js like Alpine, which is a client-side version of this. And now I will be honest and say that this poster stack seems to be a bit over-engineered. You don't need a custom CDN to do this stuff. If you use hypermedia and URL as a source of application state, then regular caching works super well. But in most cases, you won't even need that because it'll be way faster than your SPA anyways, simply because we've removed the possibility for those overfetching, underfetching, etc. issues. It simply sends the one network request it needs when it needs it. There's no other background stuff going on. The next major thing that people like HTMX for is that it's really easy to add to existing projects. And so this user says, I've just introduced it where I work. All our most recent projects were exclusively using static templating with Golang, so HTMX was a much easier sell to add a more SPA-like user experience than having another protracted argument with the architects about the pros and cons of JS frameworks. The best thing from our perspective is it is opt-in, so we didn't need to change anything about our processes and could just adopt it as and when. And so one of the hardest parts about adopting new technologies is that many are contagious. This means that it requires lots of changes in many parts of your code to use them. So an example of this is async code is usually contagious in most programming languages because to get async anywhere and to actually get the benefits of async, you need to be async in all callers of this, which eventually turns into async everywhere. Now, going from multi-page applications to single-page applications is another example of this because most of them require you to set up all the build steps for that particular SPA, figure out how to serve it, and then get it to talk to your existing code. And let's be real, most multi-page applications, backend frameworks that are non-JS are not really built to do that thing. Obviously, there's like a lot of plugins and stuff now, but it's like extra stuff that you got to do. And so what a lot of people often do in these cases is simply build a whole new SPA app, so a whole new repo for it to just handle the front-end SPA because it's so complicated. It's got so much random stuff. It's like, let me just use one that's working instead of figuring out how to make this work with my existing stuff. And so this makes it kind of contagious. In order to use this one thing, you've got to like kind of change your whole architecture to use it. Now, HTMX and Node.js in general take a different approach. They're kind of like the no build side of things. And so they're usually just browser-based JS libraries, so you can simply download it onto a page and start using it, just via a simple script tag. And so this allows for gradual adoption. So you can try it out with minimal costs and implications on the broader org. And this is why it's so easy to try it out in those like internal apps. Like most people are trying it out first in their org with internal apps, seeing how great it is. And that's how it's kind of getting more adoption because people see how awesome it is, how easy it is to use. use and go from there. And it's so great because you don't have to build anything. You don't have to include anything. It's literally just a script tag. You can do that anywhere. And so more generally, technologies with these attributes that are kind of like low build, low setup, non-contagious, really kind of libraries instead of frameworks typically are easier to compose and thus more maintainable over time. And so I think this is a really good sign for HTMX that people are having this really good experience with it, that they are able to kind of do this gradual adoption, especially in these older things that were just stuck on MPAs for a long time, because it really kind of shows the path to greater adoption in more orgs and stacks. All right, so not all of the feedback about HTMX has been good. And so one of the bad things, the bad themes around HTMX is that it kind of lacks a paved road. When I'm talking about paved road, it's usually like a good agreed upon way to do very common thing. And this is often a problem, especially for adoption for places, because if they can't find a good way, or they kind of try a few things and they can't find the paved road themselves, then they're going to bounce off and they're going to have a bad experience. And so this user asks, I do think HTMX can replace a lot of the React cases, but where I'm still struggling, where I still see myself using React, is for component libraries. And then they list a bunch here. And if you've used React at all, there's tons and tons of different React libraries for components and styles and stuff out there. And so they're saying, I found those to be a major productivity gain in smallish teams where we don't have a design system. We haven't created our own, library of styled components. And so that's the problem they have. And so, to start, HTMX apps are very similar to multi-page apps in that, and that's good because there's a lot of technology that just works out of the box. We've been building multi-page applications for decades. So anything that works for those, and there's already every programming language has support for these, it just works for HTMX. So that's great. Now, the problem generally is that these SPAs have held majority mindshare for the past decade, and thus general knowledge of these techniques and modern mainstream convenience libraries are not as prevalent as React, Vue, Angular, etc. And I would say in the past decade or two, really web dev has exploded. And so because these things have mindshare, they MPAs just can't really compete on a lot of this stuff. Now, the good thing is that, all your favorite React, Vue, Angular, Svelte libs, all these convenience libraries, all these styled components, they mandatorily render down to vanilla HTML and CS because that's what the browser understands. And so this means that there's nothing preventing these things from coming to Low.js land and working, therefore, out of the box with multi-page applications and HTMX. But it will take some work unwinding these things from their heavy build states because, all of these, they're just build heavy, they're all DSLs. So you had to build things to work within their weird domain-specific ecosystem. And now, in order to get them to work out of the box for other things, we have to unwind all that random stuff that you had to do to get it to work specifically for this and just make it work for the web, which is honestly what it should have done to start with. And so if you want to use these kind of heavily customized styles in a ready-to-use way, kind of drag and drop, then it might be more work to try and move to HTMX, especially if you're deeply invested in that stuff. And so this might be, this is a valid point if you're used to that maybe you don't want to go for there. That said, there are a lot of technologies that you can set up pretty easily. So personally, the way that I do this is I use Tailwind CSS for base styles, Daisy UI for base components, and then in my, I build F#, which runs on .NET, so I use ASP.NET. In my build step, I simply just bundle the Tailwind CSS and Daisy UI and serve it from my app. It's pretty simple to set up. And so most things should be relatively easy to get back to this kind of simple build step that you can kind of run from anywhere that runs NPX or something like that. From there, you can kind of build your own styled components. So I do this sometimes, but I typically just use Daisy UI's base components. But for those things that I do want that I'm going to reuse in my app, I just build coarse interactive islands. And I think that's a better way of thinking about HTMX components. They're a little bit coarser grained than you might think of in a SPA, which will take a little bit getting used to, but I think overall leads to much simpler, more maintainable components in the long run with this paradigm. Now, more generally, I think it will take some time to get back to kind of large multi-page applications and HTMX mindshare in terms of, convenience libraries and guides for how to do common things. But given the sustained popularity of Low.js over the past year, I think it will happen sooner rather than later, especially as more backend devs move to full stack and they're like, this is how I did this easy. All right, the next bad HTMX trend is that HTMX is not a silver bullet, but a lot of people are kind of just choosing it for everything. They're like, JS bad, HTMX good, I'm going to use it for everything. And that's not great. This happens with a lot of new technologies that come out. People ride the hype wave. They try to use it for a lot of things, and maybe it wasn't built for those things. And so it's maybe just a bad choice. And so for this user, I should have added context here, but basically they were trying to build kiosks and they were previously using a client-side heavy framework that worked well in kind of offline conditions, but now they decided they wanted to try HTMX because they're like, JS bad, HTMX good, let's build it with this. Now the problem is that these kiosks have to operate with less than favorable network conditions, which means they're probably offline a lot. This is like exactly what HTMX is not designed for, but the team in question have bitten the JavaScript bad meme. I'm watching the project gradually disintegrate. And so HTMX is very good at making modern web apps simply. Now, when I say web apps, it's online, okay? Like a website, you know? It's HTMX great for websites because it's online, but it's not a silver bullet. So as soon as you need to build something that works offline, so therefore it's not a web app, or that needs very low latency, client only changes, so something like a video game would be an example of this, then HTMX is probably not the best choice for this because one, every interaction basically needs to be online. And two, because you're doing a network call for every interaction, it's just going to be slower than you probably want for a video game that needs to like update at whatever it is, 25 FPS, 30 FPS or something like that. Okay, so that's all the feedback we got from people, but I did want to kind of show one open question that people hadn't covered that we haven't really seen feedback from yet. And that is, does HTMX scale for large teams and code bases? So overall, HTMX seems to make it very simple to build modern web apps. We've seen lots of success stories from small teams and small to medium code bases. The question is whether this scales to large enterprise teams and code bases. And the challenges there are often a bit different than what we see in the smaller teams, which gives me pause. So the first thing that is different about enterprise teams is they really need to be focused on maintainability. This is testing, type checking, and convenience at scale because there's going to be lots more devs who have to maintain a lot more code, and they're going to have a lot less context on each of the code that they're changing for their purposes. And so if we don't have good checks in place here, the code quickly becomes a ball of mud and it becomes impossible to maintain. The next one is the human scale, right? So like with more devs making more changes with lower context, we are going to have a higher risk of failure because we simply don't know everything about the code anymore. And so we really need good ways to prevent human errors, but also to onboard people easily to new code bases, new areas of the code that they haven't seen before. And for a related discussion on how I kind of think about these problems and how to solve them at scale, you can check out this post here. Now, my main concern with HTMX is that there's still a bit of raw string logic. So we're building front ends connected to back ends based on raw string URL paths with logic embedded in markup via raw strings. And so we kind of want to avoid this stuff, right? This is basically like writing code without type checks, without compile errors, oftentimes without runtime errors in these cases because HTMX is just kind of bolted on. So there's nothing that's going to be like, I asked this thing that didn't exist, or I asked it and it gave me something I didn't expect back. It's kind of just raw string issues. And so at scale, this is kind of like building in dynamic languages, but worse, which has a lot of room for error. And so, you know, these load-bearing raw string URL exist in all apps, but the raw logic is usually constrained, again, by types or at least by runtime checks. Like this thing doesn't exist, but that doesn't really happen in HTMX. And so this signals to me that there's a risk this stuff gets brittle when we have dozens of devs changing it each week without tests, type checks, or convenience libs to hide it. And so, you know, in general, I think this is totally a skill issue. Obviously, if you're highly skilled in this stuff, it works. But at scale, our code approaches the lowest common skill of the developers in us because things will change without us knowing or reviewing the code or whatever. And so this is something you need to worry about in these larger teams. Now, I don't have an answer to this yet, and we'll likely need to wait a while for enterprises to onboard and run it in prod for a good 6 to 12 months before we hear back. But this is something I'm very worried about, and so something I'll be watching closely. Next. So overall, I'm a huge fan of the Node.js movement. I built most of my apps in 2024 with HTMX, and it's been great providing simpler, faster, modern web development. Now, I plan to keep building with this architectural philosophy till a better one comes around, and you can kind of see the ham stack, which explains more about my philosophy. Question for you is, what's your experience building and running HTMX apps in production? And what are the biggest pros and cons that you've seen? If you like this post, you might also like why you should choose HTMX for your next web-based side project and ditch the crufty MPA and complex SPA. You might also be interested in HTMX versus Alpine. Which should you use for your web app? And finally, the ham stack, a simple scalable tech stack for building modern web apps fast and cheap. That's it for this video. Thanks for watching, and I'll see you in the next one.